Alright, so we're off and recording. Yeah, if you don't come to the SLP, you don't get credit for it. So, but if you turn in the report, you get points for that part of it. And let's see. So questions, comments, etc. So PA5s that were available as of about yesterday afternoon, I graded, posted feedback if there were any deductions, and that should be available in Canvas.
I'll be turning mine in a couple minutes here.
Okay.
I could have turned it in yesterday actually, but I was like, well, it's the last assignment, so I might as well use all my slip days.
Get your money's worth out of those slip days, you know.
This one wasn't too hard. I thought it was going to be harder.
If you get it dialed in just right, it's not bad. If you don't get it just right, it can be a real pain.
Yeah, so basically, it's kind of weird how both sides of the computer they're both instances of the game are basically just playing by themselves.
Yeah, yeah.
I don't even have to change anything on how I handle turns or nothing.
Right, it's an interesting possible metaphor for life somehow. Like, we all kind of do our own thing, and sometimes we think we're doing stuff together, but maybe it's all just, independent actors. But we're following the same script, so it looks like we're actually interacting more than we might be. But that's too deep for a Monday, I think. All right. So any lingering questions on PA5?
It's not so much related to PA5, but how do you make event-driven code look good? Because my end result for PA5 is spaghetti.
Huh. So in general, I would say, designing your classes carefully helps a lot. So keeping, code and data near each other in classes, knowing when to make separate classes versus when to keep things in one class. Modularizing functions so that, maybe your mouse click code is, 2 or 3 statements, but those statements, involve calling methods that do other things. But it's for me, it's very common to write code, and the first time I write it, sit back and look at it and have this feeling of like, oh, what have I done? This is some kind of Frankenstein creation, and go back and restructure it to make it cleaner. But I could not have done that up front because I didn't know what exactly the code was going to look like, and I may not have understood how it logically breaks into pieces until I started writing it and tried to make these different pieces go together, and realized, oh, there's something else I should have been designing around. And so, I mean, it's an iterative process, and the more you do it, the more I think you develop this kind of insight up front for what's going to make this come out looking fairly clean and being pretty easy to follow and debug and maintain. But it's definitely not very clear in the beginning a lot of times. You've got me curious to go look at your code now.
Well, you already. Oh, I'm guessing you didn't. Did you not look at the code this time around?
I look at the code for kind of low-hanging fruit, just to make sure I'm seeing the kinds of things that I'm expecting, but I did not go line by line through people's code the way I did in, say, PA1 or a lot of PA2. Because if the code is got a major problem, it's not going to work, right? The quit button won't quit, or the clicks won't transfer, and so on. So PA5 is of the type that, if it plays correctly, I can be pretty confident the code is doing the right thing. And I'm not super concerned about like cheating and stuff like that at this stage of the game, so I don't do a lot of digging into the code unless it doesn't work. And if it doesn't work and someone is talking to me about that, then I'll dig in deeper and see what's going on.
Okay.
So I have this totally amazing cutting edge tablet by Cooper's. It's not a bad tablet. It was cheap, cost wise, on Amazon. I got this for teaching in person for spring before I decided not to teach in person in spring. But I have my whole teaching setup here. I've got, a 55-inch monitor in front of me. I've got my laptop. I've got microphone and document cams and all this stuff, and transitioning back to in-person will take some adjustments. So one of my nods to that was getting a tablet, because I can't use my computer anymore to look things up, because that's what I'm going to be showing the classroom. So I got this tablet, and I haven't really used it much yet because, not in person yet. But what I wanted to do for today's lecture was just touch base on Android development. Not that Android is a part of this course, but most Android development, at least traditionally, is done in Java, and most of the code is event-driven. And most of it is GUI focused, and so this kind of goes along with the things we've been doing with respect to PA5. And I just kind of wanted to do this as an example of, hey, you know how to use IDEs, you know how to do Java, you know how to do events, you know how to do canvases and painting and repaint and stuff like that. That gives you enough background to switch to a totally different environment like Android and develop apps for that. And so I just kind of wanted to go through this. Just, it's not going to be on the exam or anything, but it's our last lecture class for the year. Wednesday I'm just going to do review and final questions related to the exam or anything else in the course. So for new material, just kind of wanted to just go through this mostly just for fun, and as an example of stuff you can do with Java and with some of these concepts. Yeah, question, comment?
Yeah. So you talked about using events, event-driven code, and how you can press a button, or you know how in the IDE you press a button and it creates a little event code block for you.
Mm-hmm.
Would you go in detail about kind of what each line of code does, so that way, because I think eventually in the workspace, so expect us to make a event code, but not like automatically made for us. So I was wondering if you could go more in detail about that.
Sure. Yeah, let's go back to Eclipse. Actually, I may have some notes I can share with you. Hold on one sec. So this is mainly, like when you right click on a button and you say add an action listener, and you get something like this. So let's make a Java project. And let's make a main class, which will be a JFrame. And so the usual setup we've been doing, let's put an absolute layout manager here. Let's take a button and drop it in here. And then let's write some code for that. Sometimes my buttons don't work. All right, so here's our usual setup. And we run this code, and every time we click the button, it says click. So this is this thing that that I've alluded to before, called an inner class. So this first line up here is wrong window. This first line up here is just constructing a JButton object. And then this is doing a bunch of things all together. The first thing it's doing is it's calling the addActionListener method on this button. But in the same statement, it's declaring an object of type ActionListener. So we see the new keyword, new ActionListener. And it's also defining the body of that new object, and in that body it's defining a method called ActionPerformed. All right, that's like 4 or 5 things happening all at once. We can break those apart though, and do this in a way that will perhaps make more sense to us. So let's get rid of all of this. So now we've just got, our plain old code with a button that does nothing. All right, so let's add an action listener to that. So I'm going to create a new listener called ML. And this is going to be a mouse listener. It doesn't exist yet. It's a class I have to define. But I'm going to create an object named ML, which is a my listener, which is going to be a version of a mouse listener. And then I'm going to say, okay, so let's use this J button that we've constructed. So this is button, new button. And let's add an action listener. And the action listener I'm adding is this object ML. So this is the line that's actually connecting the event with a piece of code. And I'm saying, hey, when this action takes place, when the button is clicked, right, this object ML is the thing that's going to take care of responding to that event. I have to write ML in a very specific way. Well, ML is an object of type myListener. myListener has to be a very specific thing. So let's go ahead and create a new class, myListener. And we're going to put a new keyword on here, implements. And we're going to say implements action listener. And we'll have to import this. All right, so what does implements mean? Implements means we're writing a class that follows a particular blueprint. It's not the same. Okay, if we just say, you know, class whatever, we can put anything we want in that class, any methods, any fields, and so on and so forth. If we say class whatever extends something, we can still put whatever we want in that class, but we also kind of inherit these methods and fields from the thing we extended. When we say class whatever implements some interface name, it says, okay, that interface is going to tell us certain methods we have to implement, we have to write. So it's a little bit more structure on a class in the form of, hey, since you're implementing an action listener, you have to create a method with a certain name and a certain signature. In particular, we're going to have to create something called action performed. And you notice my listener is squiggled here. And if I hover over that, it'll tell me the type my listener must implement the inherited abstract method actionListener.actionPerformed. And quick fix, add the unimplemented method. So I can add a boilerplate chunk of code here, which is just a method called actionPerformed. And so I'll put my click message in here. All right, so what have we got here? Let's follow the pieces. We created a J button. That's just constructing an object. We constructed a myListener. What is a myListener? Well, it's just, you know, it's a class with one method in it called actionPerformed. ActionPerformed for us just prints out the word click. So we constructed this myListener, and then we said, let's add that as an action listener to the button. That's the thing that says, hey, when the button gets clicked, use this object, ML, to respond to it. So when the mouse click occurs, the event handler will look at this and say, hey, we're supposed to use this ML object. What is ML? It's an object of type myListener. And it will look for a method named actionPerformed. And if it finds that, it'll go ahead and call it. So this line right here says when you click on the button, call action listener inside this object. And if I name this something like, you know, Z action performed, I get compile errors, right? Because there is no action performed method to call inside ML. So it's based on the signature. It's got to be action performed. It's got to take an action event as an argument. And so if I run this, I click on the button, I get my click messages. So this is the untangled way of doing all of this. Doing all of this. This is the inner class version. And this is breaking it out explicitly. Does that help?
Yeah, it seems like inner classes are like kind of hard to get used to since you're kind of putting a class inside of the class.
Definitely. You're putting a class inside the class, and you're putting a method inside that class inside the class. But if your IDE does this for you, then you kind of, once you make peace with it, you don't even really think about it. But yeah, it's a shortcut of doing this and then having to explicitly create a separate class and put that method inside it. So it's just kind of a convenience thing.
I got a couple questions.
Okay.
First, can you re-explain about the difference between implements and extends? Because I guess it wasn't very clear to me when you first said it.
Implements is basically saying, hey, if you're making this class that implements action listener, you've got to have a method called action perform that takes an argument of type action event. If I decide to make a method that takes an action event and an integer named I, it's not going to compile. I'm going to get an error message saying, hey, you need to have a method called action perform that takes an argument of type action event. And I don't have a method with the required signature. So implements basically says this is what's called an interface. An interface is a description of methods that you need to have as part of your class. And that's really all it is. It's just putting this extra requirement on your class of, hey, you got to have a method with this name, this argument list. I can put other methods in here.
Well, because action perform is a method of action listener.
Say that again?
So action perform is the method of action listener, correct?
Action performed is a method that's described by this interface called action listener. So I don't know if you can read this because it's really small, but it says the listener interface for receiving action events. Class is interested in processing an action event. Blah blah blah. Using the components add action listener method. So let's do this. So action listener has one method called action perform, takes an argument of type action event. But since this is an interface, right, we're required to write this method. So it's kind of a little similar in feel to extending, except that we don't inherit this method. We have to actually write this ourselves. If we extended a class and that class had an action performed method, we would simply inherit that, just like we inherit the toString method from the object class. But when you say implements, you're saying, hey, make sure that I write my own version of all the methods that are required for this interface. So for an action listener, it's just one method called action performed.
I was going to ask a question about, can you give us more examples about other classes, maybe sometime today or maybe on Wednesday?
Examples of what classes?
More examples of inner classes.
Oh, anytime that you add a event handler, you'll see an example of an inner class. So if I go to my JFrame and I say let's add an event handler for component resized, right? There's another inner class. So add component listener takes an argument of type component adapter, right? It's got to be an object of type component adapter that includes a method called component resized. Well, here we've defined an object of type component adapter. We've constructed a component adapter, and in that constructed object, we've defined a method called component resize, takes an argument of this type, and then that all gets passed as the argument to add component listener, which is a component in the JFrame that that expects a component adapter. So anytime that we're adding event handlers using window builder, it's doing it by way of this inner class mechanism. The alternative here would be I could make, my component listener, which implements component adapter, and I could write a method in there called component resized. and I would probably need to write some other methods also for moved and so on and so forth. And then I could take the name of that object, construct an object of that new type, and then I could just pass that as an argument to add component listener. And we may get to an example of this in Android, depending on how far we get in that. If we start playing with GPS stuff, we'll see an example of creating a listener and adding that. All right. So yeah, Android. And like I say, this is not part of the course per se, but it's, I think, useful in terms of some of the things we've been doing and where some of the stuff goes. So Android is a fun environment to develop in, primarily because Android devices are so available, right? You can go to Safeway, and in the checkout line they have Android phones, and for $20 or $30 you can pick one up. And the stuff that we're doing, here, where we can develop apps and put them on our phone, we can do that with any Android device, and it doesn't have to have a SIM card or work on a cellular network. We can use the Wi-Fi radio inside and just use this as a portable internet device. But we can still write apps, and we can write Java code and use them to drive apps and push those over to the device and so on. You don't need a license. You don't need to pay licensing fees or developer fees or anything. This is all freely available. And what's cool is, even a fairly inexpensive phone, like a $30 phone from the checkout line of Safeway, probably has a GPS inside, has a Wi-Fi radio, has the ability to do maps, has the ability to do, Bluetooth probably, has an audio subsystem, will probably handle email and web browsing and all this other stuff. I mean, it's truly a portable, web-enabled device. And being able to write our own apps for this, really unlocks a lot of potential power. So a number of years ago, I had a friend. He was a good friend in school. He started digging into trying to make a solar-powered plane. And his idea was, he wanted a glider that would basically, during the day, use solar panels to drive motors that would increase its elevation, and then at night it would just glide and slowly lose elevation. And if he did this right, he imagined he could keep it from crashing. It would get up to 30,000 feet during the day and maybe fall down to 10,000 feet overnight, and so on. And he worked on this for a number of years, and he wanted to have some kind of GPS system and a radio for sending out a beacon periodically to let people know where it was, and all of this stuff. And as he worked on this, it was during the period of time when phones were starting to become more powerful. We started talking about smartphones instead of just phones, right? And in the end, he finally realized he was inventing a flying cell phone, basically. And that, just a plain old cell phone at that point did everything he was trying to do, except the power management and the aerodynamic part. So phones are a great platform for just kind of jumping into and hacking around on and so on. So one thing to know about Android is it is not like C, right? It is not like Linux. So when we run a program on Linux, written in C or Java or whatever, basically you type in the program name, hit enter, the program starts to run. And it runs and it runs and it does things and it gets input and makes output and so on. And at some point it either exits, or you hit Control C, or it crashes or whatever, and the program is done. And Android is not like that. So Android, we talk about the life cycle of an application, and it's a very different kind of feel. So when you click on an activity, it calls a method named onCreate, and that calls something onStart and onResume, and your activity starts running. And the activity usually is in the foreground, so you hit your email button, and now you can see your email window and read your messages and so on. But then various things can cause that to pause. For example, if you hit the back button, or if you click on a different application, that activity leaves the foreground. It's no longer visible. It has not actually gone away though, right? So it can pause, and you can return to it, and it will go back to running, or it can stop, but it's still loaded into the system. And once it's stopped, if you go back to it, it'll call an on restart and go back through start and resume and so on. And sometimes the activity completely finishes, or you select your recent apps and swipe across to make it go away, or the operating system decides, hey, you haven't used this app in X amount of time, we need these resources. But in some situations, your app will be destroyed, and that's when the activity actually shuts down. But just because you're running an app and then you switch to a different app doesn't mean that first one has stopped, right? It's in a state where it may or may not be taking CPU time, it may or may not be doing something, but it's hanging around until this eventually gets destroyed. So people, when they first start using phones, they discover, you can get a list of recent applications and swipe them to close them. And they think that doing this will make their phone run faster or take less memory. And you're defeating the whole application management system of the operating system, which knows that these apps were out there and they were taking resources and not being used now, but it's deciding, when to get rid of things and when to restart things and so on. So this is one thing to keep in mind, because sometimes your app will feel like it's exiting, but then you'll rerun it and it'll be where you left it before. Your variables that you changed values of will still have those changed values and so on. So that's one thing that can be a little unusual. All right, so assuming you've got a device for yourself, and if you have an Android phone, you may not want to do this on your super critical Android phone. I've never had anything bad happen from this. I've never bricked a phone by doing development like this and so on, but you never know. So I've got this tablet that like I said, was just for teaching in person, and so this is a handy target for Android. So the first thing you want to do is become a developer. And most phones work like this. So come down to your settings and scroll down to About, and then scroll down to the build number and start clicking on the build number. So click that a bunch of times, and it says you're 3 steps away from being a developer. Click it again, you're 1 step away from being a developer. Click it once more. Bingo, you're a developer. Alright, so confirm your pattern. It's a super secret pattern. You are now a developer. That's it. Right? Could not be easier. They do this because, someone who's not, someone who doesn't know what they're doing might, stumble across, let's turn on USB for debugging, and inadvertently do something. So you have to do this deliberate step that you probably wouldn't normally do. Most people aren't just going to start tapping on the build number, right? So it's like the Clark password on engrcs.com. It's just to kind of keep away the low-hanging fruit. So you're a developer. All right. Yeah, right? All right. So let's go back here and let's look at System and Advanced, and now you've got a list of developer options. and so you can turn it off by hitting this switch, or you can leave it on. And the main one we care about is USB debugging. So we're going to flip that on, and it'll ask us to confirm, that you want to allow USB debugging. Yes, and that's really all we need. So I believe this absolutely will not work on iPhone. And iPhone, I think you have to go through some hoops, some bigger hoops. I don't know how this works with Kindle. I was wondering about this actually recently, because Kindle is a really different version of Android. Most devices have their own version of Android, but they stick pretty close to.
Kindle doesn't even let you install Firefox.
Yeah, so you can't use like the Google Play Store.
You can't use another browser other. Oh wait, no. I was able to get Firefox on there.
Oh, cool.
But I had to install an APK and whatnot.
Right.
Which is super annoying.
Yeah.
But yeah, all its settings are all super locked down. Everything's all babyfied.
Yeah, it would be interesting to try this what we're gonna go through here, and see if it works. Because yeah, Kindle is Android based, but they're pretty far from the tree.
Okay, fair enough.
Say again?
Burn the Kindle.
Yeah.
Oh.
But I've got to say I love my Kindle. I have like a 10-year-old Kindle, and it's just a book reader. It has an experimental browser, right, that I've never used, but it's just a book reader. It's e-ink, so it's reflective.
Like the Kindle Crush 3rd edition. I have that too.
Yeah. And I love it because there's no email alerts that come in when I'm reading a book, and it's reflective, so it's not emitting blue light at night and popping my serotonin and all that. So yeah, I like Kindles. They have a place. All right, so we're a developer. We have USB debugging turned on. We're good to go. So I'm going to leave this aside for now, and let's go ahead and run Android Studio. So if you want to dig into this, I don't have a lot of patience for a lot of websites. This website is actually good in my opinion. So developer.android.com. It's a good place to find information about all the different classes and methods that we're going to be working with. And it also has some good tutorials. So this was how I first got into Android, which was many years ago. And it changes, every several months, every year. There are small changes, there are big changes, and a lot of what you learn will no longer work. So it's a moving target. And I spent several hours this weekend, a few hours this weekend, getting back to where I could make a basic Android app. Because the last time I did this was, 6 months ago, and none of that stuff worked anymore. So this is part of why, you get paid a lot of money as a developer, because you have to keep up with, that was last week, now we're doing something different this week, right? And it makes sense. It's not just gratuitous, buy a new version of our phone. It makes sense because the capabilities of these devices increases all the time. The security concerns increase, and we're in a new design space, right? Smartphones did not exist 20 years ago. And what did you envision you needed to do to develop an application 20 years ago? That's probably very different from what people realize today are best practices. So if you were doing this, as part of your job, you would be keeping up with this. And every time there was a new release coming out, you'd be going through the release notes. Maybe you'd be going through some training, and you would keep up with it. I do Android development a couple of times a year, right? And so it's a longer process for me. Yeah.
I manage an Android app at work, and every time, we have stand-up meetings. Every time we have the bigger ones, I'm always like, okay.
Yeah.
Anything big in the new Android update that's going to screw us over.
Mm-hmm.
Same with iOS.
Yeah, and most likely the answer is yes.
Well, recently there hasn't been too many things.
Oh, good.
Fallen us too hard, which is nice. A couple times though, we
I
just
told you to.
What was that?
You're jinxing it. Be careful.
Nah.
Yeah, I don't buy too much into jinxes. No, I do knock wood.
My desk's wooden, so
Yeah, good.
knock knock.
So I've already downloaded Android Studio. I downloaded this a few times ago, and I have an older version. I'm going to shamelessly ignore its requests that I update because I don't know what's going to break if I do that. So I'm doing this under Linux. I've tried to do exactly the same things under Windows, and side by side, it feels like a very different experience. The response times and such just seem to be a lot worse under Windows for whatever reason. So here's my startup window, right? And I'm just going to go ahead and say start a new Android Studio project. And I'm going to begin with an empty activity. You can choose what kind of activity you want, and it will create, different kind of templates, boilerplate code for different things. And basic activity is not quite right. So empty activity seems to work best. But if you want to design for your watch or your smart TV or your car, you've got all these different options and different kinds of activities. We're going to go pretty bare bones here. I just want to get through like a very basic, let's put up some buttons, let's make them clickable and respond to them. Just to get through the parts that are different from what we've been doing with say, Swing, but still have enough Java to be recognizable. So I'm going to start with an empty activity, and I don't know what I'm going to call it. I'm going to call it,
I have a question.
yeah.
So if you were to make the app for Android and iOS, the same app, you have to write those two apps in completely different languages, right?
As far as I know, yeah.
That's so annoying.
Well, this is why, sometimes you see a really, really, really awesome app on Apple, and it's like it's not available on Android. And, Android, anybody who could get to the code could make an app and push it out, but you got to redo it. So, and I've never done Xcode development, but it sounds like it's pretty fun.
Yeah, Xcode sucks.
Does it?
It's awful. It's
Okay.
like Android Studio, but even worse.
Yeah.
It's rated like a 1.2 on the Apple Store.
Out of 1.3 or out of 5?
Out of 5, yeah. It's like number 1 for coding, and then it's the worst rated.
Fun.
Because you have no choice but to use it.
Yeah. So Android, we use Android Studio. When I first did this was a plugin for Eclipse. And so you were developing under Eclipse, and that was really, really wonky. It was glitchy, it was incredibly slow. And then they switched to Android Studio, which is basically, I think, a wrapper around IntelliJ. And IntelliJ makes Eclipse look like VI, basically. It's so powerful, but it's also so in your face. And for Android, I like that because I don't really understand most of the details of the Android API. And so I'm constantly using the IDE to, write my code wrappers for me, or import, this class or that class, or show me a outline for this method that I need to implement in this interface, and so on. So I kind of switch modes, and I become the, sit back in the armchair and point and click style programmer for these things. Partially because, like I say, I really don't have a lot of experience with this where I could, bang the stuff out in VI, for example. Someone said, what do you think of XML? So XML is a markup language. We'll look at some XML inside our development here. It's just, it's a markup language. It's pretty old, so it's well adopted and well standardized, and it's extensible, right? That's the X part. It looks a lot like HTML. You put tags inside angle brackets, but there's no rigid syntactic structure. You don't need a tag of this type or that type. You can put anything you want in it. And so it can be a useful way to organize information that allows you to, add extra things down the road. So maybe you're storing mapping data. And so you can say, here's a tag called map. And everything inside this block from map to the end of map has to be a bunch of sightseeing information. So there's going to be a name of some object and a latitude and a longitude. And you can just make, a bunch of entries that store, points of interest, latitude, longitude. And then maybe you decide, hey, you want to timestamp this information, know how old the last recorded sighting of this point of interest was, and so you can add a new tag that would say, last timestamp. And then maybe you want to record how many people have reported this same point of interest, and so you can add a tag saying, report count. And so you can kind of modify it on the fly and things like that. So XML is how they drive a lot of the stuff in an Android app, and so we'll see some specific examples of that. All right, so I'm going to put in my name. We didn't get to talking about packages. Packages are a way to basically take the classes that you're writing and the class files that will be created when you compile and put them into a directory structure. So this is going to go into a subdirectory called com, and underneath that will be a subdirectory called cell matrix, and underneath that will be a subdirectory called A223 Monday. And my stuff will go in there. You can use Java or Kotlin. Kotlin is a little bit of a more relaxed version of Java. It has less rigid typing requirements and so on and so forth. I've done some Kotlin development. I don't find it as comfortable as Java just because, experience. And this is a Java course, so we're going to stick with Java. And you can choose what API level you want to run at. So older phones, might run API version 22 or 24. Super new phones will run, API 30 and 10.0 and so on and so forth. And this is about a year old, so it doesn't have the latest, greatest. So I'm just nominally going with Android 8, which was called Oreo. That was a number of years ago. And it'll tell me, this will run on approximately 86.7% of devices. So if you're developing an app for other people to use, then you care more about this stuff. All I really care about is the name. So I'm just going to go 223 Monday, and I'm going to say finish. And then a bunch of stuff is going to happen. All right, so I've got a little bit of code here. I've got this whole directory tree of my Java file and all this other stuff. I'm ready to do updates. I'm not going to do those. And let's go ahead and yeah, it's figuring stuff out. So it knows about my phone right now. Right, so this is a Shenzhen Yidong Technology Company Limited CP10. That's my tablet. There we go. So, if you plug in your device and it does not find it, you probably need to go into developer options. and turn on this USB debugging. And if you turn that off, then this goes away. And so there's also the ability to work with virtual devices. So I can come in here and I can say something like, let's open the Android Virtual Device Manager, and I can create a virtualized device. So I have a virtual Pixel 3, I have a virtual Android watch, and I could create a new virtual device and say, hey, I want a Pixel XL, right? And you can create this artificial Android device, and it will show you a picture of it. Well, let's just go ahead and do that. Let's make a Pixel XL, and let me do something sneaky here. I gotta ignore those error messages. Alright, so here's my Pixel XL, and I'm going to go ahead and start that device. Oh, it's already running. Alright, so here's my virtual phone. Oh, that's a big one. And so if I don't have an Android device, right, I can take my apps and I can push them to this virtual phone and test them out on there. So this is, you know, it knows the date and it knows the time and so on, and I can bring up a browser. And I can accept the terms, and I'm not going to sign in. And, you know, it's a web browser. So this is cool, you know, if you don't happen to have a device that you want to develop on, you can develop on this make-believe phone. And it's kind of creepy how well it works. But it does. But I've got my tablet, so I'm just going to shut this thing down. And it's a little slower to work on this, but it works surprisingly well. So those are called Android virtual devices, AVDs. So I've got my tablet. I'm going to turn debugging back on. And the first time that you do this, it will usually give you a pop-up and say, hey, so-and-so is trying to turn on debugging. Do you want to allow that? And it'll do the fingerprint exchange so that you can, you know, make sure it's not somebody else trying to hack your device. So we're connected to this device. So let me go ahead and just show you like where we're going with this. So let me bring this to the home screen. And I'm just going to hit this run button. And so it's installing the app. Oh, it did not finish. Yeah, it went off my script. me try this once more without deviating from my carefully prepared. I'll call this next test. Okay. Well, I guess it's gonna make me, yeah, fun and dangerous. It's gonna make me actually do something. All right, so let's just go ahead and make a simple app. So first thing I want to do, I want to come down here under Resources, and I want to come under Layout, and I want to say Activity Main, and I'm going to click on that. And I'm going to close out these. All right, so here's a picture of my phone, and these are, you know, different widgets that we can take and drag and drop into here. So there's buttons, there's text views, there's password fields, there's image viewers where you can display a picture, and so on and so forth. And this is one of the things that changes frequently. And so here's my way to make this work in short order. I'm going to right click on Constraint Layout, and I'm going to say Convert View, and I'm going to change to a relative layout. And this is going to make my life a whole lot easier. Now if I zoom in here, I've got a little thing on the top that says Hello World. Right, that's a little text view. And it's like, you know, a J edit box. It's just a thing that we can put some text in. And I don't know, I'm going to change this to a tablet, just for kicks. All right, let's see if I can push this over. Dang. I broke something.
This is a good time to take a 5-minute break while you debug this.
We're getting close to the let's take a 5-minute break line.
Oh, okay.
Where I try to act like this was all carefully planned ahead of time. Alright, yeah, let's go ahead and take a 5-minute break. And let me mess around with this for a few minutes. So we'll come back at about 11:06. Alright, let's see if I can get this to work. Let me try one more thing and I'll go back to my screen share. What I did not try was doing this while I was doing Zoom and a document camera and a screen recorder. And I may be getting into trouble because of that.
I was watching PewDiePie and you talking. I was like a solid 2 seconds. I was like, wow, this is a weird background noise.
Nice.
Does anyone else have the issue where they get double notifications from Canvas?
I get a weekly digest and an automatic update, and so sometimes I get double there. But I also got my notifications in Spanish one day last week, and I don't know what that was about.
Nice.
Like, you mean like push notifications by email?
No. So well, push notifications mean not email, right?
Yeah, but you can also get email notifications as well.
That's not a push notification. I'm just busting off. yeah, regular notifications on your phone.
Yeah.
Eden, I don't know if that's the case because my settings haven't changed in like a year, and they used to only give me single notifications, but for like the past 4 months, I've been getting double.
Interesting.
Speaking of notifications, my mom, her phone is set to get like notifications about events or whatever from Clark,
Mm-hmm.
advising and stuff, and I don't know how to change it because there's no settings for notifications that's accessible anywhere in my Clark account.
Good question. Are they like rave alert notifications?
Well, some of them are rave alert notifications. Some of them are like notifications about upcoming events at the campus or upcoming things for like fairs or whatever.
Mm-hmm.
From like our college advising or career services, stuff like that.
I am not sure. You could try IT for a starting point for that. But yeah, I'm not sure how to get off of those.
I just need to change the number so it's coming to me. So.
Yeah. Good question. I would start with IT. I think they could at least direct you to where to find that. The rave alerts, I think, are pretty straightforward because they send around notes now and then asking people to make sure they sign up for that. I had a former student at OSU who got an alert one afternoon during lunch about a earthquake drill, and the instructions said, to get under the table and cover. And so they did that, and it was a Clark alert, and they were at OSU. So in the middle of the lunchroom, this person all of a sudden jumps underneath the table and covers their head. And yeah, good engineer. That's how good reputations are made. All right, so let's go ahead and put some things on here. So I'm going to right click on this layout. I'm going to say convert view, and I'm going to change to a relative layout. And let's just take a text view and drop this in here somewhere. So my text view is in the upper left corner. It's got text which says text view. And if I say, let's go ahead and push this out to my phone or my tablet. So there's my tablet, and there's my app, and it says text view in the corner. And this is called test 1, so I can drag this in here, and anytime I hit test 1, there's my app running. So getting something to happen is pretty straightforward. Not so straightforward as if I want this text view to be somewhere else, it does not comply. And it tries to anchor everything to the upper left. So this is the most maddening part of Android for me, is the layout manager. And these layout managers are useful if you know how to use them. But I would really like to be able to say, hey, I want a text view right here, and not have to negotiate this with the tool. But you have to negotiate. So here's what I'm going to do. There's these little circles, right, on each edge of this box. I'm going to click and hold on this left circle, get this line, and just drop it when it's pointing the left edge. I'm going to do the same with the circle on the top. And once I do that, now I can take this box and I can put it where I want. And it's going to remember, oh, go this far from the left, this far from the top. And so now I have a text view, sitting over here. And if I push that out to my phone, that will go ahead and put my text view over here now. Alright, so let's put a button in here. So I'll drop a button in, and same thing, I'll anchor this to the left. I'll anchor this to the top. I can put my button down here, and you know, I can change the click. Like I can call this go, and I can call my text box. I can change the text to, you know, hello. And now if I run this, I've got my app running, and it's got my button. For some reason it called it search, and I've got a text box and so on. So why did it call this search? I saw it autofill something on this button. I'm just going to call it go. Okay. And so, you know, there's a build message down here saying it's building, it's installed, and then there's the app running. All right, so we can drag and drop widgets onto here, and we can move them around, and they will stay where we put them for the most part. And you know, you can resize these things and so on and so forth, all the stuff you would usually expect. All right, I can also name these things, so I can change the ID of this to message box, and my button is called go. So the next thing I'd like to do is you know, respond to button clicks. So if I pick this object and I come down here under common attributes, there's a option called on click, and this is a place where I can specify the name of the method I want to have executed when the button gets clicked. I don't have any options right now. We haven't written any code yet. So let's go into our Java main activity. So this file right here, and let's write a method for a button handler. So our button handler has to be written as follows. It has to be public void, and I can call it whatever I want. I'll call it my click code. And the signature is it has to take an argument of type view. And we can do whatever we want in here. So if I don't have these import statements, I don't think I should have done that.
Can I ask a question?
Yeah, go ahead.
So, what is a package argument on the or what does package do on the very top of the code there?
So package is a way that we can say, hey, I want all of my class files to go into a subdirectory. And a package like com.cellmatrix.test1 will put these files under a subdirectory com/cellmatrix/test1. And it lets us create a hierarchy of class files so that if we say com.cellmatrix.test1.something, it will look for it in that proper path in the directory tree. Instead of having all of our class files always be in one directory, which is, you know, whatever directory we happen to be sitting in. And so when we start working with classes that are coming from somewhere else, you know, like with linked list or swing or things like that, this is a way to organize the class files and put them into different parts of a directory structure. So we've stuck with the default package throughout Eclipse. And I don't know if Android Studio will let you do that. It strongly recommends you don't. I don't know if it's an option, but you just specify a package, and it's where your .class files end up ultimately.
So it's kind of like a way of telling a program where to save the files, or
Basically, yeah.
Okay.
All right, so down here there's a button called LogCat. And this is a way to see what's going on in your Android device. And so I'm getting all these messages that are being generated by different things happening on my tablet. Update Wi-Fi connection, and a power watchdog, and so on and so forth. And so if I download my app to, oh, I'm getting that again. Okay, so I need to import a view. So we're going to do what we do in Eclipse sometimes, right? Just hover over this, hit the import class option. That'll add an import statement. There's code folding, so you know this is hiding a bunch of statements of the same type, and so on. I'll go ahead and push this over to my device, and on my LogCat window, there's all kinds of messages coming up, but my button still doesn't do anything. So let's make something happen. So there's a static method in a class called log that I can use to add messages to this log window down here. So I can make a statement like this, Log.i, and you take two string arguments to this method. The first one is a tag. In this case, I'm going to use test1. And then my second string is going to be whatever message I want to display. I'll just say the go button was clicked. Alright, we're going to import log. And now if we run this, and so this is running. If I hit the go button, nothing happens. I meant for that to happen. Alright, so I created a method called myClickCode, right? But we have not tied that in with the button yet. So let's go back to the layout. And on the go button, under this onClick option, if I hit the drop down, now I have the option of calling myClickCode. So I'm going to do that. And I'm going to run my code again. And now if I hit the go button, I get a message saying the go button was clicked. Alright, so we've got this basic linkage set up now. We have a way to take an event in our app and have it fire some code. In this case, Go is calling myClickCode.
So why can you not use system.out for printing output to the console?
Because there really isn't a console. I mean, I have access to this because I'm hooked up through a USB cable and I'm running what's called Android Debugging Bridge, ADB. But in general, on just a device by itself, if I hit a button, there's really no console for it to print to. And if I've never tried doing this. I'm guessing it's just not defined. I don't know where that's going to print to. It's an interesting question.
Probably the system, I assume.
Ah, okay. So that shows up here also.
So wait, does the log.i actually have a different output stream, and that's why it's showing like test1 and system.out?
Yeah, so I think it's probably wrapping something around the log class. But yeah, so you can system out print line and display a message here also. That's cool. I didn't know you could do that. But in general, that's not going to get us anywhere with a standalone app, right? Because this is only working because I happen to have a debugging cable hooked up. All right, so how is this button connected, right? There's no code in here that says, hey, when you click that button, call this code. So if you go into the XML file, so here's our design window. If I click this button up here, and this is the second hardest thing to figure out in Android, this button up here in the upper right corner is magic. That shows the design window. If I hit this button, it will show me a split view. If I hit this, it'll just show me the XML. And this is the XML corresponding to this layout. And so what is it saying up here? Well, there's some boilerplate stuff up here. There's a text view. That's its name, message box. This is its dimensions. This is where it's laid out relative to other things. Here's the text field. Here's my button. Its name is called button. This is where it's aligned relative to other things, but it also has a tag saying on click is my click code. And this XML file is used when the app is run to know, hey, when you click this button, you should call a method called myClickCode, which it finds in our Java file. So this is a little more data-driven than what we've been doing with Eclipse and Window Builder and Swing, where we added an action listener with the name myClickCode to be called when the event happens. This is all done through XML to connect these things together. But if we live in the design view, right, then we have options for setting these various pieces of information through these parameters. So if I take this button and I make it bigger, I don't want to do that. If I take this button and I change the dimensions, then if I go back to the XML, right, those different dimensions are in there. So now I got a big button. All right. Well, this is just Java, right? So we could count the number of clicks that we've made. So we could do something like this. Right, so we could display a message that shows the count and increments the count each time that we hit a button. And so if we run this, every time I hit the go button, I get a new count value. And if I close my app and I rerun it and I hit the go button, it continues from 7. Right? My app did not actually exit even though I hit the home button and made my app go away. It's in this different state in its life cycle, but it's still there. So now it's at 11 and 12 and 13. And if I come back to my recent apps and I swipe that one away, and then I run this again, right, well, it got destroyed, so this time when I ran it, it went through the startup, which included, among other things, doing this initialization, setting my count back to 0. So that's one thing to keep in mind, or another thing to keep in mind, the life cycle business. All right, let's output onto this text field. So we've got this text field. I named it message box. It has a set text method that I can use to display information. I would like to display something on that. The message box is not created in my Java code. There's nothing in here that says, text field message box equals new text field. The fact that this thing is a text field named message box is part of the XML. Right, it's the fact that I have an ID of message box and a type of text view. And so we need a way to link the code together with the XML. And this is done through a method called findViewById. And so this is the other quirk. And once you get through these 3 or 4 quirks, then you can kind of be off and running, and you could, you know, take your or your dots program and turn it into a Java app pretty easily. So let me make a text view. So this is a text area on which we can display some info. We'll go ahead and import the class for text view. So here's the onCreate method, right? This is what's called when an application begins, this code executes. This is the initialization that I can do in the beginning of an app's life cycle. So let's find our message box. So I'm going to say message box equals, and I'm going to say findViewById. And then my argument here is always going to look like this. It's going to be r.id. And then the name of the object that I specified in the design window or in the XML, which for us was message box. And r.id.messagebox is 100010. It's an integer, right? That's the ID of this device. But I can retrieve that ID by you know, I can put that ID in and I can get back the actual message box object. So I'll just say r.id.messagebox. And I'm going to cast. So, you know, in C, if you have a character and you want to change it into an integer, you can say parentheses int in front of it and it'll cast it to an int. So message box is supposed to be a text view, so I'm going to cast that in here. So I'm going to say text view. And make sure that the type of thing that comes back from this find view is a text view. And so when my app is created, when it starts running, message box should be this box up here. And so now in my Java code, I'm just going to say set text. And I'll put my count out on there. Alright, so let's go ahead and run this. And here's our go button, and every time I click that, my message box up here changes to the new count. Alright, so we got input, we got output. We've got basically all the things that we need to be able to build apps. So that's kind of the start of all the happiness of Android. But it's really just a starting point. So a lot of this is similar to what we've been doing, right? We have different kinds of objects we can drag and drop in here. We can connect methods to actions by doing things like, you know, specifying an on-click method and so on. And then it starts to get a lot more complex. So one of the things with, you know, say developing an app for a phone is you're not just living in isolation. It's not like when you run an app, that's the only thing that this device is going to be doing. There's all this other stuff happening all the time in the background. So if I turn off all my filters, I'm getting like all the activity for everything that's happening on my tablet at all times, which is a lot of stuff. Right, 192.168.0.1 is my router, and the thing's wireless radio is constantly, like, you know, interacting with the router, and there's power checks going on, and and all kinds of stuff. And if I do something like if I open up a PDF document, then a bunch of stuff starts happening, right? And so this is a debugging option, and right now I'm being as verbose as possible. I'm saying every message being generated by every application on the system, I want to see that message here. And you can filter it to specific applications and so on and so forth. So there's all this stuff happening all the time, and I want to write a program that's going to, read the GPS coordinates of my device and display the latitude and longitude. I can't just call the GPS and say, hey, tell me what your latitude and longitude is, because guess what? There's probably other things that are interacting with the GPS. And the GPS is a shared resource. The Bluetooth radio is a shared resource. The phone subsystem is a shared resource. So you have to work and play with all the other things on the system. So this is kind of like an extreme version of calling repaint instead of paint. Right? When we try to display information on a J panel, I said don't call paint, call repaint. And repaint says, hey, I've got a paint method. When you have a chance and it seems like a good time, call that for me. And that call is synchronized with everything else that's going on. I just realized we're down to 4 people in here. Ah, fabulous 4. There's going to be tons of at least karma points for some of you. All right, so we have to work and play with everything else that's going on inside the system. So we do a lot with listeners. We do a lot of saying, hey, I want to register as a listener for this type of event or this type of activity, and when something happens, let me know. We also have to follow a whole set of rules that are specific to, perhaps the version of Android that we're running. For example, if we want to make a socketed connection, if we want to open up a connection to a server somewhere, we cannot do that from this Java code. Android will force us to do this in a separate thread, because otherwise there's a possibility that your main application is going to hang up, and the developers of Android don't want a situation where you click on an icon and your window freezes, right? It's not the desired user experience. So if we're going to do something like create a socketed connection to a server somewhere, the system will force us to put that in a separate thread. And if we try to do socket code from here or from here, we'll get an exception when we try to build that app. So there's all these details, right? All these little nuances that you have to pay attention to, and follow pretty much to the letter to get things to work. And this is part of the frustration or joy of working with a system like this. It's so detail focused, but if you dot all the I's and cross all the T's, really cool things can happen in the end. So let's play around with GPS. Yeah, go ahead.
So in your statement at line 19, I'm still new to what you mean by text view and findViewById. What does the text view in parentheses represent?
That's what we call casting. So findViewById is a method, and it returns an object of some particular type. I don't know what type it is set up to return, but since I'm trying to get an object which is a message box, which for us is a text view, so message box is a text view, I want to make sure that the thing that I'm assigning to this left-hand side is a text view. So this is not exactly how it works, but you can think of it like this. findViewById might be a method that's declared to return something of type object. And I want to make sure that this object is treated as a text view, so that I can assign it to message box, which is also a text view. Well, it's claiming that text view is redundant. but so I could remove that. It's kind of like when you malloc something. Malloc returns a pointer to null, which you can assign to anything, but if you're trying to assign to a struct node, you can put inside parentheses struct node star and say, hey, take the thing that malloc is giving me, let's treat it as a struct node star, and then set the left hand side equal to that. All right, so let's work with the GPS, and there's probably a 50% chance this is going to work in the 20 minutes or so we have left. But we'll give it a shot, and this will give us another example of an inner class kind of situation. So there's a GPS inside most of these devices, and part of what's happening is this is constantly pinging the satellites that are overhead and getting new position information, and then different applications can say, hey, let me know when that information changes. And so you go through the Android API documentation, or you find sample code, and you cobble together the following bits and pieces. So let's make a location manager. I'm just going to call this LM. And this is a whole class that needs to be imported. And so down here I'm going to say LM equals, and a location manager is a thing that's in charge of tracking location. So how do you track location of a phone or a tablet? Well, you can use the GPS receiver inside. You can use network information. If you have a SIM card, you can use cell tower information. So there's different ways that you can ferret out the location of a device. And so we're going to use a method called getSystemService. And the type of service that I want is going to be location service. This is context. And that's a class we're going to have to import. And I'll get a message over here saying, hey, I need a location manager, but what I found was an object, right? So this getSystemService is kind of a general purpose workhorse method that will get us back whatever kind of thing we ask for. If I ask for a location service, I get back an object of type location manager. But it doesn't know that that's what it's going to return. So this method, when it was written, is said to return an object, right? That's the type of thing that it returns, is an object of class object. But my LM is a location manager, and it does not want to take an object and stuff that into a location manager box. So this is where I'm going to use a cast. And basically, I'm taking on the responsibility of saying, hey, this thing is going to be a location manager. Go ahead and cast it into such an object, and now set LM equal to that. It can be kind of a silly thing, or it can be something that is really important. All right, so the next thing I'm going to do is I'm going to say, hey, when the location changes, I want to be updated. And so I'm going to call a method in this location manager named request location updates. And now I can say, what location updates do I want? So and these are all just static fields that have been defined. So I'm going to say location manager dot network provider. So I'm going to get this off of my network. I can specify a minimum update time in milliseconds, so minimum of 5 seconds. A minimum update distance of 10 meters, so if we move more than 10 meters, I want to get an update. And then the name of the listener that I want to have called when the location changes. So this is going to be location listener. And this is a class we haven't created yet, an object we haven't created yet. Alright, so make a location listener. So I'm going to make a location listener class called myLL. And I'm going to make a loc listener. And down here I'm going to construct my location listener. Alright, so down here we've got a message saying request location updates. Alright, so alright, let's go ahead and create myL. So I'm going to say create class my location listener. And here I'm going to use this implements keyword again. So I'm going to say this implements a location listener. And I'm going to have to import that. So this is where I'm just really leaning on the IDE here, right? This is all stuff I would have to like look up and learn and type in. And I'm kind of letting it tell me what I need to do. So now this line is red and it says class myLL must be declared abstract or must implement the abstract method on location change parentheses location. So this is an interface. I'm saying I'm implementing this location listener. Well, a location listener requires me to have a method called onLocationChanged. So I'm just going to say implement the methods, and it's going to write me outlines for 4 methods. So there's an onLocationChanged, onStatusChanged, onProviderEnabled, and onProviderDisabled. And so I'm going to add a message here. I'm going to say location changed. I'll import my log message. And it's throwing in these names of the arguments because that's what it does, but they're not really there. All right. So what have we got here? We've got a location listener of type myLL. myLL is this class I just wrote that implements a location listener that has this onLocationChanged method. And down here I'm going to say request location updates, and basically when the update changes it should use the location listener. In particular it should call the onLocationChanged method, and I should get a message saying the location changed. Got to keep the compiler happy. So we've got a squiggly line under here. It says missing permissions required by location manager. So this is the next difference about this Android development versus say Eclipse, this notion of permissions. So you run an app sometimes and it says this app needs the following permissions, right? So in general an application cannot access the GPS, cannot access the radio, cannot access disk storage inside your flash card, and so on and so forth. You're forced to live in a sandbox by default. But you can specify that the application wants to use certain permissions, and then the user can grant those permissions on their device. So in this case we need some permissions. We need course location permission. access course location, and access find location. And so I can just say, go ahead and let's add that permission. And so now if I look in my XML file, in my manifest, there's a flag here which says, hey, we use the permission access course location. And I'm going to add find location also. I don't know which one I need. So this manifest file is sort of the high-level information about the app, including its name, what package it's in, and the permissions that are required. Alright, I got more complaints here. So now it's telling me that, hey, I require permissions that the user may not have granted. So I can add a permission check, and I get more code here. So this is a big long if statement. If activity compatible, check self permission this, comma, access find location is not equal to permission granted, and access course location is not equal to permission granted. That really should be an or. That looks like a bug. And then we can do all of this stuff. So let me just throw a message. It says need permissions. And we're not going to use this, but you know, it gets rid of the squiggly red line. Alright, so now what have we got? We've got a location listener that I've constructed right here. And we've got a location manager that we got from the system. And now we're saying use the location manager to request location updates from the network provider, and if we get an update in position, call location listener. In particular, call the onLocationChanged method, which is going to print out a message in our log file. I'm going to do one more thing. I'm going to use my message box, because unless I take this tablet and walk around, I think we only get one shot at updating the GPS location. So I'm going to make it count. So I'm going to have my location listener output latitude and longitude through that message box, which means that I need to know how to get to that message box from in here. So this will be a flashback to some of the things you did in PA5. Text view, message box. And I'll import this. And this is the text view we can write to. And down here, when the location changes, I'm going to say messagebox.setText. And I'll say latitude equals, and this argument that's passed to the location listener is going to be an object of type location. So I can say location dot, and that object comes with methods like getLatitude. And get longitude. Alright, so the last thing I need before we try this is I need to make sure that my location listener knows what message box is. So I'm going to make a constructor. And I'm going to say public my LL, and I'm going to take an argument of type text view called message box. And I'm going to say this dot message box equals message box. And I'll save this for future use. And then the last thing I have to do is in my actual Java program, when I construct my location listener, I'll tell it about the message box, which I found out up here by using findViewById. All right, that's like, you know, a month worth of trying to figure out Android development compacted into a short period of time. But let's go ahead and run this and see what happens. So there's our app, and I'm not terribly hopeful. So let me switch this to information. And so this is fine, except nothing happened. We did not get a latitude or longitude from here. So we can set this up to give us a message saying, hey, we need permissions. We didn't add that code. But I'm just going to go into my apps, and I'm going to click on test 1. And under permissions, no permissions granted, it's by default denied the location permission that this app wants. So I'm going to click on this, and I'm going to say allow location to be used. And now that's under an allowed permission. And so now I'm going to come back and I'm going to hit test 1. And maybe not. Well, like I said, 50% chance this will work. Let me stop this and let me rerun it. And there we go. There's our latitude and there's our longitude. And that is, you know, Vancouver, Washington. And we got our log message over here.
Everyone knows the location.
Yeah. All right, so this is, you know, not a slam dunk by any stretch, right? This takes some digging into and some trial and error, and this is an area where sample code really is your friend, right? Where being able to go through sample code will seriously help. But that Android usually just do Android developer, and you get down to developer.android.com, and this will get you the entire API. So if I want to know about location manager, right, I can come down here. And there's a documentation on the location manager class. And you have an option. You can look at your code in Java, or you can look at it in Kotlin. And the sample code will change accordingly. And, you know, similar to the Oracle documentation for Java. So all the methods and the types of things they return, and you can click through to these. It's all hyperlinked. You know, so GPS status was deprecated in API 24, and so you need to do something different now for that, and so on. But you know, all the information is in here. It can be tricky to find sometimes, but it's actually a pretty decent resource. It's better than most API documentation I've found lately. And then there's tutorials, and Stack Overflow is not bad, but a lot of times you start Googling some of this stuff and it will take you down rabbit holes that aren't really where you want to go. That's okay, but just kind of be prepared for that. All right, that was possibly useful, possibly not. Hopefully something in there of use. Like I say, you know, the goal is not so much that we want you to learn Android development as part of CSE223. It's really just this idea that you know, once you know Java, doing these kinds of things, the details change, right? what the heck is location manager.network provider? Well, it's a static field that I found in the documentation, right? What is manifest.permission.access find location? It's another static field that you find in the documentation. Or I right-clicked and said, go ahead and add a check for my permissions, and you know, it fills in that code for me. But this should not throw you into a major, I have no idea what I'm doing kind of mindset, right? We don't know what these specifics are, but you know, this is an if statement. It's comparing two things to see if they're not equal. This is passing some kind of value as an argument to a method called getSystemService, which is a method inside whatever this object is, which is a main activity, which is an extension of an app compatible activity, and we're casting the return of that to a location manager and saving that in an object that we declare to be a location manager. So it can feel very different from what we've been doing, but it really is just Java. And once you know how to do these few tricks, like get access to an object by using this findView, or connect an activity event to a piece of code by doing something like, you know, specify an onClick method, then you're just off and writing code, right, and doing the same thing that you've been doing throughout this whole quarter. And other systems are similar, right? So if you're doing game development, if you're working in Unreal or you know, some other system like that, it's the same stuff over and over again. And the first time you go from Eclipse to Android, it's not entirely pleasant. It's a lot of scratching your head and trying things and looking up error messages and so on. But when you get it to where it works, right, the next time you go to a new system and you try to do the same thing, it's not as difficult. You're used to, you know, oh, this kind of thing is happening. Okay, well, I'm gonna go here to find out how to deal with that. And eventually, you know, you can be handed a new system that you've never used before, and start developing for it, and you know, be up on the air in an hour or so maybe. And that's the learning part that takes place beyond the classroom learning, right? Which is kind of learning how to learn, right? So that's sort of meta level knowledge of how do I pick up a new programming language? How do I learn a new IDE? How do I work with a new API? Those sorts of things. And it gets easier the more you do it. And it's pretty fun because it exposes so much cool capability that that we can just tap into pretty quickly. All right, well, that's all I got for today. Thank you for sticking around. I appreciate it. Hopefully there was some value in this. And Wednesday, I'm just kind of planning to wrap up the course, talk about the final exam, go over a list of topics, maybe stuff like that. So nothing in particular planned. Bring some questions. Come by office hours tomorrow if you like. Otherwise, have a great one, and I'll see everybody next time. Thank you.